All right, so going into problem 3 from the midterm. Now, before I get too much into this, as I'd mentioned right away, this was actually one of the problems that when I went through ahead of time, I look at every problem before I start, and I was evaluating which ones. I thought this was going to be one of the easier ones for me. It's a math question. I tend to do really well on the math questions on the practice ones. And, well, I'll tell you what happened when we get there. So, as usual, let's go ahead and evaluate these first few cells, set up our data. There's our data has been incorporated. It's been set up, loaded. All right, they give us some information. Each one is a list of dictionaries. There's a list of strings inside of those. Similar above. That's great. Okay, Bayes' theorem. We're actually using some really straightforward probability in this one, so I'm not going to go into explaining any part of this really in a complicated kind of a way. In fact, I'm pretty much going to blow it off entirely. So let's go ahead and actually start with the questions, because honestly, you didn't need to understand this in order to get these next few questions correct. You just had to understand what it was you were being told to code. So I'm not going to worry about explaining the probability here and how Bayes works. And we have a naive Bayes model. The probability of some event given x is equal to, and there we go. We're not going to again worry about that. It does tell you should have understood some of this already, but we're going to have to figure out our priors. What are the priors for each class? Okay. And to do that, we're going to write a function called prior. It takes a class of values as inputs, returns a dictionary containing the priors. In there, we're going to use class names as keys, and the probability of each one occurring as class values. So, and it tells us how this would work. We'd have data, here's our data, and your function should produce this set of priors. And if you did this, you could have worked out what you're saying is, what is the probability of class 1 occurring? Well, we have class 1 once. Let's see, it's once there, twice out of 8, that's 2 out of 8, that's 0.25. So that's all you had to do is figure out how many times does a class show up and divide it by the total number of entries inside of data. So this one I'm pretty sure you could have had a very straightforward answer. Of course, no, I didn't have a very straightforward answer. I decided to do something kind of complicated. I was like, well, I have a list. I want to build a dictionary. I want to see how many times something shows up inside of that. So, well, first thing I did, that sounded like a default dictionary of int. I was going to be importing items, and I wanted to add up how many times things happened. So I did. I was going to create a counting dictionary. And now what I did, I created my integer dictionary. And then what I did is for every element inside of the data, I would go ahead and say, well, let's go ahead and add that element to my dictionary, or at least increment its value by 1. So now I know I have all the classes in my default dictionary, and I know how many times they occurred. So the only question is, how many things did I have total? Well, I had the length of the data. That's how many items were inside of the data originally. And then what it says, well, let's take my results, and I don't need it to be a default dictionary anymore. I want it to be a regular dictionary. And then for every key and value in my dictionary, what I wanted to do was replace the value. So go to the result key and replace it with the value divided by the total. So I'd turn those counts, those frequencies, into relative frequencies. And once you did that, go ahead and return the dictionary and it'll be done. Kind of a longer way to do it, but this is how I saw to do it. And it's what I did, and it passed. And then, of course, we had to run this to get the priors for the entire data set, which it did. So here's the priors of our data set using all of the data. So this I did right away, no problem. Then we did the Gaussian naive Bayes model. They have some explanations here what the math is. To be honest, didn't even look at it. Went right down here in the exercise. Write the two functions, mean and variance of the vectors. Compute mean and vectors. Well, as I've said before in other questions, I don't like reinventing the wheel if I don't need to, especially for a straightforward thing. So I imported my statistics. And for mean, it was just return the mean of that vector. It's already there inside the statistics library. I wasn't going to reinvent it. Now, vector, here's a funny thing. I'd forgotten. Statistics has a variance. However, by default, it's set to do the variance of a sample instead of variance of a population, so it's calculated a little differently. So I was actually wrong when I first implemented it. Instead, I'm doing it manually, which is just to get the variance of something, I need the mean of the vector itself. And then I create a temp list to save some individual values for each part of the vector. Because for each element in the vector, I needed to go ahead and keep that value, but I needed to square it. The difference between the element and the mean that we'd already calculated. So now we have a list of the squared differences. And now we just need to return the average squared difference. And doing that, we'll get the variance returned. And it worked. And now we had to implement the function likelihood for exercise 1b. This is where I got stopped cold because I knew what I needed it to do. I couldn't figure out how to make it do what I needed it to do. I understood I was going to get X and Y. Y was telling me which class each of these were actually in. And then I'd use these classes to figure out, and then I had to return what were the means for class 1 or class 2, depending what they told me up here. And I tried all kinds of ways of doing this. I looked at hard coding in all the different classes they could have given us. I went back and looked, and there were like 5 different classes. And I thought about trying to build a dictionary that would just handle all 5 every single time. But then it would have to go through that and pull out what wasn't given to us in the particular question. And I was just stuck for the longest time. So this is one where I got to this part of the exercise and stopped and realized even though I could do the math, my dictionary and list comprehension was actually holding me back for a while. And you're going to see my solution for this is much longer than theirs. But it was what I was forced to do because I didn't know how to do it in a more succinct way. But I did come back to it after I finished the rest of the test, and I was able to finish it. This question took me the longest time. In fact, this part of this question took me the longest time. So I'll try to explain what I did. I'll be honest, my explanation for this question may not be the best. But say one more time what it is we're looking to do. They're going to give me X, and they're going to give me Y. Y is going to tell me for each dictionary in list X, which class that dictionary belongs to. And what I needed to return was, by class, what was the mean for the features provided, and what was the variance for the features provided. So they thought they set us up for success by giving us these 2 dictionaries to start with, because we're going to need to return them. Well, first thing I figured I needed to know was what classes am I dealing with? Because I'm going to use that when I build my dictionaries. So what I told to do was give me a set of those classes, but I want it in a list because I'm just more comfortable dealing with lists. So I did that. Next, I know I was going to be saving this stuff inside of a dictionary, so I created a dictionary just to start with. I'm probably going to need it. And now what I wanted to do was start breaking down where my information went. And what I was going to need to put inside of my distributed mean, distributed variances. So for every element in classes, which is just a list of the classes that are in my information, what I told to do was in my result list, go ahead, put that element and have it ready to accept a list. And in my results that I was going to return, well, I knew I had to return for every class, I had to return those results. So, and that was going to consist of a dictionary. So go ahead and prepare it for each class that I need to return. Here, things getting a little bit messed up. Let's get this cleaned up again. Okay. So what I've done at this point is I had a list of all the classes that need to be in my results because I created the set of those classes. And then in my dictionary, I prepared it to accept a dictionary of results. Okay. Now what I needed to do was segregate the list inside of X, the list of those dictionaries, into the respective classes that they would be in. So first off, I'm going to increment through X. So I'm going to use I. And now what I did was for every element in Y, because Y was telling me what order my dictionaries in X were in with respect to class. So go ahead and let's increment through Y, and it's going to tell me where everything goes. Well, if the first item in Y is class 1, then in my result list, I want class 1, I want whatever that element is, to add on the first entry or its respective entry in X. And then increment Y. So what increment I? So it's going to increment through Y, identifying which class things belong in, and then in my result list is going to place in the correct list, class 1, class 2, class 3, all the way through class 5, the corresponding entry in X. So my result list will now be broken down by class. I will have result list. I will have a dictionary with up to 5 keys. Those keys will have lists of the vectors of X that I need to deal with. So I will have now segregated my X information down to which class they belong in. Once I have that, I can now deal with those classes. And the way I did that was I went back to my list of classes. So for every element in classes, what I want to do was say, well, what are the keys in the result list for that element in the first entry? Because that first entry is going to have the same ones as all the others. They're broken down, they'd all be identical. So I just need those keys. So let's get those keys. And then what I need to do is I need to increment over those keys. So for item and keys, I created a little temporary storage place I called Do It. I was just thinking of a certain actor in front of a green screen shouting that I should just do it. And now, what I want to do is increment over. That should be range. Let's get some extra spaces in here. That's getting annoying. I need to go over every item associated with that class. So I'm going to do that. I'm going to add on those items. Okay. And now I'll get the mean and variance of each one of those. So the mean is equal to the mean of Do It. And the variance is equal to the variance of Do It. If that's spelled wrong, I'm getting an error later. Wait a second. Okay, yeah, these are right. Check my indentation because I have a habit of getting those wrong. And what I've done is I've now calculated potentially feature 1's mean and variance for this particular class. So now what I need to do is go ahead and put that inside of my answer that I'm going to be returning. So let's go ahead and return that class's feature will now get the mean and the variance for that class's feature will get the variance. I said it and then I wrote it, the variance. So that's what we did. I worked through, segregated my information down by class, then I built what would all the values be for feature 1 of this first class, get me a mean, get me a variance, put that inside of my results. Then go through, let's go to the next item in the keys, which would be feature 2, get all of the feature 2 items, and get me a mean and variance, and then build that into my response. So on and so forth until I've worked through all the features for every class. And once we do all that, let's go ahead and return our results. So this was probably, like I said, the hardest part for me to get through. It took me the longest time, and it wasn't because I couldn't figure out what I needed to do, is figure out how to parse my for loops and how to actually structure it so it would pull the information and send it where I needed it. Now I'm going to go ahead and run this, and we'll see if the tests work. Make sure I've got all my indentations correct before I do this. So I've got my means, I've got my variance, classes is a list of a set, result list is a dictionary, work through the classes, get my result list ready, have my actual results ready to build. Let's increment through y. Okay, now we're going to increment through the classes, build it in, work through each keys, now work through each item inside of it. Yeah, that should be it. Yeah, that means I don't need this line down here. And let's see. Okay, oh, I've got FOIT. One simple typo. So again, if you're not real familiar with these tracebacks, make sure you get pretty good at it. Honestly, skip right to the end almost every time. And that's where my problem was. I didn't check my spelling. So try it again. And that's it. Now we're going to interpret our results. Not that bad. I believe this is all automatic. Yep, nothing I have to do here. And it makes nice, pretty outputs. Okay. Now we got to part 2, which again wasn't that bad. I'm going to go through a little bit here. I'm not going to break down the mathematics again on this. Honestly, again, you did have to know a little bit about it. First thing is you had to know is up here. You understand that the vector was going to be the maximum of these possible values. So a little bit more difficult to work with. And of course, they talk about don't do it the way that makes it easy to work through, because if you do, you run into problems that we had before because you're doing with logs. So we end up modifying a little bit, and we're looking at the max of values. So let's go through our log likelihood. Log likelihood isn't that bad. They're going to give us a vector, and that's why it's only worth a single point. They're going to give us a feature vector of one data point, a dictionary of means for a single class, dictionary of variances for a single class, and we have to return the results. So I may have done this a bit more complicated. Go ahead, let's get my keys. What am I going to be dealing with here inside of my vector? Get me a list for my dictionary, or a list for my results, I'm sorry. And then for every key they gave me a set of keys, let's go ahead and put this in. And I just typed in the formula. I'm going to cut and paste it. Oh, there's something I've forgotten to do, and I'll put up here in just a second. I literally just put in the formula, which you'll see is right here. Now, if you notice, I have log. So let's just bring in everything from math. So I have log, no problem. So once we've done this for every value inside of our keys, now what we have to do is just sum all of those up. And for this one, I'm going to use fsum because I know fsum handles floating points, a sum of floating points better than just doing sum. So I used fsum. And go ahead and return our final sum. So this was a straightforward. I just returned the data as they gave it to me. Their solution was a single line of code because, as usual, most for loops, if you're iterating over a list, you can just put it inside of a single line of code, and that's what they did. Otherwise, I don't think there's any difference. I use fsum. This was just me being cautious. I want to make sure it was going to do the floating point addition correctly. I didn't have to have done it, it turned out. Could have just used sum. Whoa. Oh, for math. Works better if I spell that correctly, doesn't it? It doesn't. Oh, don't drop those keywords. All right. And I now have an error. Return final sum. Because I'm supposed to return final result. There. Now we actually have to implement the classifier. This one I think was too bad. Again, they're going to give us a list of test samples, then give us the means and the variances that we used through likelihood, and the list of priors. Well, get that Y prediction back. Get some blank space in there. Okay, so first off, what classes are we dealing with? When you know what classes we're dealing with, now we know. So let's go ahead and work through our list inside of our X test. What are we going to be doing? We're going to increment through each of them, and we're going to check them. Now for the element in each class, what we need to do is we need our past means, and I wrote past instead of past. We need our past means. Well, that's not too bad. It's what was the mean for that class. Same thing for the variance. What was the variance for that class? So now we have it. Now for term 2, this is going back up here, we had some probabilities and some logs that we're going to get. Well, term 2 isn't that bad. Well, it's the log. Oh, I'm going to need something here, I think. Yeah, I'm going to need that. Okay. It's the log likelihood, our function that we just wrote, of which item in X test we're currently working with, and we're going to pass it the previous means and the variances, and it's going to give us our term 2. And then term 1, well, that's just the log of what was the prior probability for that class, right here. And we want the max of those two items. But we're going to get to that. Because what actually goes inside of check'em is a tuple. And we'll end up going through those in a moment. Because once we've done all that, now we can build Y and our prediction. So our prediction is going to be predicated on which of those are more. So let's go ahead and work through those. We want to find the maximum of them. And it's either going to be check'em, but the key, and this is where I used item getter to get it. So I have to pull this in for our tuple. I think I've got some parentheses mistakes going on here. Let's see. Item getter. There we go. Thought something looked odd. Okay, and since I've used item getter to iterate through here, I need to bring that in. Okay. So what it will do is it will append in a y the maximum of the item that's inside of checkum or the tuple that I've set up here. And of course, let's return those predictions. Let's see. I don't need this line then. Of course, there's always a typo. I don't think I can make one of these without making several typos. There's an error. Let's see. Term 2, log likelihood, pass mean. Oh, pass mean. It should be pass means. Typo. Pass vars. Because it's supposed to be just pass var. Reverse my plurals. And that's it. Again, the secondary test, this pass, it wasn't a problem. Summary, no additional exercises, that's fine. But if we want to see how things would work and how accurate was it, well, let's see. It would depend on which class, true, positive, recall, how precise are we. You could spend some time going through this, figuring out. I didn't. I was trying to get the test done, but hopefully I explained my thinking. I realized that it may not have been entirely clear, especially on the one that stopped me cold. This was exercise 1B. Again, my problem was figuring out how to get it coded. We're even looking at their solution now. I'm having to spend time going through and figuring out how does this work, because their solution for 1B, well, we've seen mine. It's all of this. Here's theirs. I need to spend some time with my list comprehension in order to get that understood. And here it looks like a combination of list and dictionary comprehension. I still don't understand this solution yet, so mine was definitely different. This was, from what I understand, one of the harder questions on the test from what I saw the distributions. Problem 4, I think, had a similar distribution of scores. This was a nasty question, and especially for me, I had real difficulty with this. Like I said, I got through the first couple stages. This wasn't a problem for me. You know, the mean, the variance, I got through those no problem. But as soon as I got to 1B, this stopped me in my tracks. But I took a break, went to dinner, spent some time with a couple friends, came back, worked at it some more. I did get through it. I wish I could tell you what it was I'd Googled and searched and built my way to understanding, but I can't remember. There's so much time was spent on this, so many Google searches that didn't quite work out to try and find something that would help me. And as you can see, I really didn't probably use too much from Stack Overflow when I came up with this. It was just how could I break this down to the smallest possible pieces into lists that were going to retain some kind of order that I could then rebuild into results, because I was just lost when I was working this first time. And it's a good thing I took a couple hours break, because I was just pounding my head against a wall on this one. Once I did this, the rest of them weren't too bad. I don't know if I got too many people in a bad way, but it could have been down here, this term, that you need to get the maximum of certain values. May have caused some problems for people. But it's definitely, this was a very challenging question. So I hope you're able to get through it. And if not, I hope you're able to actually understand what it was I did. And if not, I hope you can understand what it was that they did in their solution. And good luck on the rest of them.